to be about exponential growth and decay. Actually, I'm going to record only the exponential growth, the first part, and the second part will be exponential decay. Let's explore and reason first. Explore and reason. I'll be reading in English and in Spanish version of both problems, so you'll get better understanding of the problem.
Cindy is buying a new car and wants to learn how the value of her car will change over time. Insurance actuaries predict the future value of cars using depreciation functions. One such function is applied to the car whose declining value is shown at the right. Part A. Describe how the value of the car decreases from year to year.
Let's hear it in Spanish.
Cindy comprará un auto nuevo y desea saber cómo cambiará su valor a lo largo del tiempo. Los actuarios de la aseguradora predicen el valor futuro de los autos usando funciones de depreciación. Una de ellas se aplica al valor del auto, cuya depreciación se muestra en el recuadro de la derecha. A. Describe cómo disminuirá el valor del auto año tras año. B. Representa con modelos matemáticos. ¿Qué tipo de función explicaría el patrón dado? C. Dada tu respuesta en la parte B, ¿qué se necesita para averiguar la función que el actuario está usando? Explícalo.
Okay, now describe how the value of the car decreases from year to year. What do you see here? The inputs and outputs. In inputs years after purchase, so as the input increases from 0 to 4 year, the value of the car, it decreases from $10,000 to $5,210. Now, in this case, what do you notice about the value of the car? So what do you notice in this case? You can write it in your notebook. You can use your notebook to write the information. So as the years increases, the value of the car decreases. Now, in the second one, model with mathematics.
Part B. Model with mathematics. What kind of function would explain this type of pattern?
How could you determine the relationship between the consecutive values in the table? What do you see here? You look for patterns by subtracting each number, so by subtracting each number from the previous one, or dividing subsequent values. Sketch the points on the graph and look for relationship. So you can make a graph and you can plug the values, input X values and output the Y values, which are the value of the car. C.
Part C. Given your answer to Part B, what is needed to find the function the actuary is using? Explain.
So, how is knowing the general formula for the exponential function helpful in describing this situation? So, use the prior knowledge. Use the exponential function, the original exponent, the parental function, the exponential function. What does it say? How you can come up? So, how you can come up with the answer? Knowing the general form of an exponential function allows you to use the data in the table and to write the specific exponential function. So you have to go back to the previous lesson and to recall the information. How do we find the formula for this table using this data? Okay, for students that finish the problem, you have to write the function. Write the function that models the value of the car after X years. If the car depreciates twice as fast, how long will it take for the car to be worth 1/4 of its original value? This is a challenging one. If you'd like to do that, do it. But let's go more in depth and see see the exponential growth and try it.
The population of Hillville grows at an annual rate of 15%. What will the estimated population of Hillville be in 5 years?
Okay, as you see, the population is 5,000. The annual rate is 15%. And we have to figure out the population will be in 5 years. Now, annual. The word annual means yearly. Now, the essential question to pay attention during this lesson is what kinds of situation can be modeled with exponential growth or exponential decay function. And the modeling with mathematics, in an exponential growth situation, the change in y is always proportional to the value of y itself. That is, with greater y values, the function increases more rapidly. What other exponential growth situation can you think of? Just think about during the lesson. Let's translate this in Spanish, the problem in Spanish.
La población de Hillville crece a una tasa anual del 15%. ¿Cuál será la población estimada de Hillville en 5 años?
Okay, let's see the solution, what the solution is telling us in this case. Pay attention to the exponential growth, to the words, to the vocabulary words. So these are the new words for today. You can model exponential growth with a function f of x is equal to a times b to the power of x, where a, which is the initial amount, is greater than 0, always should be greater than 0, and b is greater than 1. So the general formula is going to be function of x is equal to a times b to the power of x. And an exponential growth function has a growth factor that is equal to 1 plus the growth rate. So this is going to be the formula. The growth factor is going to be, so this is going to represent b value, 1 plus the growth factor. Growth rate. Now, in a step, let's go over with the step 1. Step 1 tells us write an exponential growth function that models the expected population growth. So let's break down the variables. Let x is equal to times in years. So this x here, as you see here, the exponent x is going to represent times in year. The a, which is here, a is the initial amount, and r, which is 1 plus r here represents the growth rate. Fx is equal to a times 1 plus r to the power of x. So the initial amount, as you see here, the population is 5,000. 5,000 times the growth rate, which is 1 plus 0.15, so this 0.15 is coming from 15%. So we're turning the percent into a decimal to the power of x. So 5,000 times 1.15 to the power of x. The function is fx is equal to 5,000 times 1.15 to the power of x. Now, step 2. Step 2, the problem is asking us to find the expected population in 5 years. Now, 5 years, what variable we have for 5 years? Don't forget the times, right? Let's go back to here how we broke down the variables. X was times in years. So here in this case, x is 5. So let's plug it in calculator. F of 5 is equal to 5,000 times 1.15 to the power of 5, because we're going to figure out in 5 years. So this is approximately 10,056.79. By the conclusion, in 5 years, the population is expected to be about 10,057 people. Let's go and try another one. let's see the concept interest. The concept interest, what the concept interest tells us. Interest is calculated, concept interest. Interest is calculated in two ways, simple interest and compound interest. Simple interest is the interest paid only on the principal. Compound interest is interest that is paid both on the principal and on the interest that has already been paid. The compound interest formula is an exponential growth function. So the compound interest formula is A is equal to P times 1 plus R over N to the power of N times T. Now, let's break down all the variables and see what each variable represents to this. So A in this case is amount paid, P is principal amount, R is the rate of interest, N is number of times per year the interest is compounded, and T is equal to times in years. Now, the graph below shows $10 at 5% simple interest and a 5% interest compounded quarterly. If you put it in the formula, all these numbers, and you'll see, and you can make the graph by yourself and see it, how it works. Let's try a few more problems to exponential models of growth. Using the structure of exponential model growth, use the order of operation when entering your number on the calculator. How can the omission of parentheses change your answer? You really have to pay attention, be careful to this. Now, let's see.
Kimberly's family invested in a certificate of deposit for her when she was born. The interest is compounded quarterly. Part A. What is the value of the CD at the end of 5 years?
Let's hear it in Spanish.
La familia de Kimberly invirtió en un certificado de depósito, CD, para ella cuando nació. El interés es compuesto trimestral. A. ¿Cuál será el valor del CD al término de 5 años?
Okay, now, as you see here, amount deposited is 3,000. Annual interest is 8% and interest compounded quarterly. What compounded quarterly means? Quarterly means is 4 times for a year because it's 4 times. And let's see the solution now. What the solution is telling us about in 5 years, what is going to happen in 5 years. Now, we're using the formula, as you see in the previous slide. We use this formula to figure out the interest compounded quarterly, which is A is equal to P times 1 plus R over N in the power of N times T. Let's break down all the numbers and give them the values. Now, 3,000 times, so 3,000, as you see here, 3,000 is the principal amount. The rate of interest is 8% or 0.08. As you see here, 0.08 is turned to a decimal number. The number of times per year the interest is calculated is 4. As we said, quarterly is 4 times per year. And to the power of N times T, N is 4 times per year, and T will leave it like that, just a variable. Now, in this case, the 8% interest is paid over 4 periods. So 2% interest is paid for each period. As we get here, 3,000 times 1 plus 0.02 to the power of 4 times T. This is the meaning of 8% in 4 periods. Now, as we add inside parentheses, 1.02 to the power of 4 times T. Now, the problem is asking us in 5 years. So instead of T in the variable T here, we're going to plug in the years, which are 5 years. And it gives us the answer of 4,457.84. Now, at the end of the 5 years, the value of the CD will be $4,457.84. Right, let's move on and practice another problem. Okay, let's see what's going to have to question B.
Part B. Will the value of Kimberly's CD be greater after 15 years if it is compounded annually rather than quarterly?
Pay attention to this question because it's very important to know and to figure out how it's better to compound it quarterly or yearly. What is the difference and what is our interest for doing something like that?
B. ¿Será mayor el valor del CD de Kimberly luego de 15 años si se compone anualmente en vez de trimestralmente?
Okay, reason. What reason? The simple interest formula is A is equal to P times 1 plus R times T. How is simple interest similar to annual compounding? How is that different? Okay, let's see what the solution is going to tell us in this case. As you see, we are continuing this as previous problem, same information, or just now calculating compounded annually rather than quarterly. Annually, that means per year. Compare the exponential function you found in part A with the annual compounding n is equal to 1 over the same 15 years. Quarterly. So for quarterly, we get the answer here. In 15 years, it's 60 to the power of 60, and we got the answer $9,483.09. Now, let's see what's going to happen yearly. Annually. Yearly, yes. A is equal to the formula P times 1 plus R over N to the power of NT. Now, 3,000, 1 plus 0.08 because it's 8%, over 1 because it's only 1 year. Now we don't have this quarterly, we're calculating only yearly, annually, to the power of n times 15. So 3,000 times 1.08 to the power of 15, and the amount is 9,516.51. So this is going to tell us, to conclude, since the interest is only complied once per year, the entire 8% interest is paid one time. The value of Kimberly's CDs will be less if the interest is compounded annually rather than quarterly. And you really have to pay attention to this information. If you're ever going to have a bank account or something, you're going to know what to do. Let's go to the next one so you get more comfortable doing the exponential models of growth. Here, you have to try it in your own. I'm going to leave this for you guys to try it in your own. I'm going to read. I'm going to give you the reading part and maybe a few hints, but not the answer.
Kimberly's family invested in a certificate of deposit for her when she was born. The interest is compounded quarterly. Part A. What will be the difference after 15 years if the CD is compounded semi-annually rather than quarterly?
Now, what do you know about the difference? Okay, here, semi-annually means is twice per year, every 6 months. So I'm giving these hints, every 6 months. Let's see the second question.
Part B. What will be the difference after 15 years if the CD is compounded monthly rather than quarterly?
Now you have to compare this. Monthly will be every month, which are 12 months. And rather than quarterly, which are 4 months, and you're going to see the difference between these two and what's going to tell you which one you prefer to use. And this was the lesson. Please, you can go back and check again the lesson. You can stop the video, pause the video to take notes, and I wish you a good luck with this remote learning.